So today we will proceed last part of chapter 6, measures of dispersion. What is measure for dispersion? So get ready everyone. Kita terus mula. Okay, so in this subtopic, we will learn on how to find and interpret variance and standard deviation for ungrouped data and group data. So dia cakap measure of dispersion means variance and standard deviation lah. Itu basically. Okay, so we will learn both for ungrouped data and group data. Okay, and then we will learn on how to find and interpret Pearson coefficient of skewness. So ada 3 benda kita nak belajar hari ni, but then very simple. Make sure get ready with your calculator sebab kita nak guna benda tu. Okay, so what is dispersion? Dispersion, or as I said before, is the standard deviation, is how the data is spread out or dispersed from the mean. Itu bahasa cantik dia lah. Bahasa pasar kita, okay, standard deviation selalunya lah. Orang akan cakap, oh find standard deviation. But then you didn't really know what is actually standard deviation. Standard deviation or notation is S is actually, tadi dia guna bahasa dispersion kan. Sebenarnya, it's bukan data. Distance, jarak between data and mean. Itu sebenarnya. So selalu orang cakap standard deviation tu apa? Nanti selalunya lah kalau saya tanya, student akan jawab balik, oh standard deviation tu sisihan piawai. Dia pergi translate. Tapi awak tak faham pun sisihan piawai tu apa. So it's actually distance between data and mean. Okay. So if smaller dispersion, the more consistent the data. If larger dispersion, more spread the data means the data is not consistent. Itu ayat dia terang-terang lah. Okay. Dari segi gambaran dia, kita boleh lukis benda ni. Sekejap Hari ni saya kena pakai laptop. So nak tarik-tarik ni berproblem sikit. Okay. Okay, ini situation kita. Kita pergi to the first situation first. Alright. So imagine lah, ini imagination kita. The straight line is our mean. Okay. Yang saya buat pangkah-pangkah tu is our data. So if this happen, standard deviation just now I said it's distance between data and mean. Kalau tengok kat sini saya letak data tu very close to the mean. Okay. If this happen means our standard deviation value would be quite low. Kecil je. Sikit je dia punya jarak tu. Tak jauh. Okay, so bila jarak kita tak jauh, our data, we can comment. Our question would be basically on how to interpret kan. Comment on the data or interpret the data means now our data would be less dispersed. Kurang berselerak sebab jarak kita dekat je dengan mean. And if it's less dispersed, means our data would be more consistent. Okay, sebab dah kurang berselerak, data kita jadi consistent. Okay, that's the first situation. Okay, second situation, sama. Imagine the straight line is your mean, but now I put the data is quite spread out. Dia berselerak tu jauh-jauh. Kan, jauh jarak kita tu. So if this happen means our standard deviation would be high. Jarak kita jauh maksudnya nilai standard deviation akan jadi tinggi. Okay, so if this happen, comment kita akan the other way around. So dia akan jadi more dispersed sebab tadi data dah lebih berselerak. Okay. And then it would be less consistent. Okay. Most of the time question akan bagi 2 set of data. So based on those 2 set, you have to find the standard deviation and then comment or interpret your data. So when it comes to standard deviation, the way you interpret the data, you must mention about dispersity and consistency. 2 item ni. Dispersed and consistent. So if it's low means less dispersed, dia jadi consistent. Kalau data kita tinggi, jarak tu jauh, dia akan more dispersed and less consistent. Itu awak fikir logik lah. Kalau ni, kalau rasa nak menghafal, up to you. But then benda ni pakai logik sebenarnya. Dengan syarat awak faham. Okay, standard deviation just now is basically distance between data and mean. Alright. So, that's for interpretation. Saya kena tarik balik. Okay. So, why we want to find the standard deviation? Just now it's about dispersity and consistency. Okay. For example, this is a situation yang selalulah involving academic, selalunya kita nak tentukan kelas ranking. For example, kelas mana yang perform lagi bagus. Contohnya ini ada two set of data, marks between students. Okay, we have two different class, MS1 and MD1. Okay, selalunya orang cakap, okay, macam mana nak tentukan siapa lagi bagus? Benda pertama yang awak akan fikir is, we find the average score. Mean kita kan, average is mean. Okay, so for this case, mean for both would be the same. So kalau dua-dua mean dah sama, takkan kita nak cakap kelas tu performance dia dua-dua sama rata kan? Tak semestinya. So how do we find apa yang kita nak identify here is by using standard deviation. Cara lain kita nak tentukan siapa yang lagi better by using standard deviation instead of average itself. So data yang lagi konsisten, maksudnya standard deviation yang lagi rendah, kelas tu yang akan lagi perform lah actually. Macam tu cerita dia. So first orang akan check dulu average. Kalau average sama, next kita akan check dia punya standard deviation. Okay. So ini situation dia lah kalau kita lukis the distribution. So imagine yang dia mean. Okay. If larger dispersion, then dia punya tu rendah kat situ. Sebab data dia jauh tau. Ini nampak macam, jangan ingat nilai dia rendah tu standard deviation rendah. Ingat, dia distance between mean. Mean ni garis putus-putus. Pergi ke data. So kalau dia macam tinggi ni, dia larger dispersion. Okay. Smaller dispersion nampak macam tinggi, jangan tertipu. Jarak dia dekat je pergi garis putus-putus tu. So dia smaller dispersion. Okay. Maksudnya makin tinggi lah kita punya distribution ni. Kalau kita panggil bukit ni, makin tinggi bukit awak, makin rendah nilai standard deviation. Kalau makin rendah lah bukit ni, maksudnya makin tinggi nilai standard deviation. Okay. So this is the formula. During exam, formula ni dibagi for both. For ungroup data and group data. This is for variance. And then standard deviation is basically set of our variance. Itu sahaja. Okay. Kita terus jawab example Saya letak satu-satu ni dalam nota. Satu for group, another one for ungroup. We go for ungroup first. Alright, find the variance and standard deviation of all the following number we have set of data here. Okay, so before start finding the variance, remember focus on the formula. Formula to find the variance is summation of x squared minus square of summation x divided by n, the whole thing divided by n minus 1. Okay, so means before substitute all of this into the formula, kita kena cari dulu satu-satu info. Okay, start with n. What is n? N is basically number of our data. Bilangan data kita ada berapa banyak kat situ. Itu boleh kira lah kan. Straight away awak kira je satu-satu, awak dah terus tahu dah. Here our n is 9. Okay, settle first one. Next one, summation of x squared and summation of x and summation of x squared. Different things here. Summation of x means every single data you add up. Tambahkan je setiap satu data. And then summation of x squared means every single data you have to square it first. After that, find the summation. Jangan pergi ambil summation x, lepas tu awak squarekan ni, awak terus dapat summation x squared. Dia tak sama. Okay, you can do this manually, up to you. Awak nak kira satu-satu, or you can just straight away compute this into your calculator. Buat apa kita beli calculator mahal-mahal kan kalau kita tak nak guna calculator tu. Okay, that's why tadi saya kata keluarkan calculator. Okay, sekarang get ready semua, keluarkan calculator. Sekejap saya adjust screen biar bersama calculator. Okay, kenapa? Sebentar ya, apa masalah dia? Kenapa dia tak nak gerak? Okay. Okay, saya dah keluarkan calculator saya. Okay, so go to menu and then go to option number 6 here, statistic. Go to option number 6, okay. And then choose one variable. Okay. After that, for sure, make sure akan keluar terus table ni. Dia ada tajuk di atas tu, X. X is basically our data. So, compute our data into the calculator. So, masukkanlah satu-satu, make sure all 9 data are compute semua awak masukkan. So, we have 6 equal 7, 10, 11 ada 2 kali. And then 13, 16, 18, 25. Done. Ada 9 data. Okay. Dah masuk semua sekali tu, tekan button AC. Tak apa, dia tak payah risau. Okay. So, in front of your calculator now dia ada statistics one variable. Sebab kita dah pilih mode statistic, kita dah masukkan satu variable just now. Okay. Go to option, button option, OPTN. Okay. And then go to option number 2, one variable calculator. Oh, okay. And then akan keluarlah set of all data yang dia dah tolong, analysekan. Kat sini jangan tengok kat screen saya, tengok kat calculator awak Okay, first row is X bar. X bar is 13, means that is our mean sebenarnya. Sebenarnya masukkan data dalam calculator dah boleh dapat mean. Tak perlu kira manually macam biasa pun, dia boleh tu. But then, for assignment, you have to provide full solution Ni masuk dalam assignment, awak kena tunjuk dalam kerja penuh lah. Tak boleh lah tekan calculator pop terus keluar jawapan, awak terus ditulis. Tak boleh. Itu awak kena tunjuk dalam kerja. Okay. Next one, summation of X is 117. Itulah yang kita nak tadi sebenarnya kan. Summation of X, bahagian yang ni. Sekejap saya highlight color kuning. Summation of X. We want to use that in the formula. So, itu yang kita nak kenalah guna. Summation of X is 117. Okay. Next one would be summation of X squared. Itu yang kita nak pakai kat bahagian depan ni nanti. Saya highlight color biru. So, saya copy lah. Summation of X squared is 1801. Okay. Settle. Okay, kalau kita tengok yang bawah-bawah tu, is actually we have the final answer for variance and standard deviation. Pergi kepada notation. For the fourth row in your calculator, do sigma squared dengan sigma. Yang tu tak payah tengok. Kita punya tu, kita bukan itu untuk population. Kita sample je. So yang simbol sigma tu ignore je. Pergi last row. We have S squared X equal to 35. That is basically variance. Dia dah boleh tolong kirakan dah. So sebenarnya pakai calculator, you already know the final answer. But then nanti kita kena tunjuk jalan kerja lah. Tak boleh lah terus tiba-tiba variance 35. Tak boleh Okay, S squared sama simbol kita dengan ni. S squared, that is the variance. Okay, next one, boleh tekan button ke bawah. Okay, dia akan keluar S pula. Okay, S is basically our standard deviation. In the calculator dia bagi juga answer 5.916. Itu nanti kita boleh check lah based on our data. Betul ke tak apa yang kita kira. Okay, ingat tadi jawapan kita patutnya variance, our answer supposed to be 35. And then standard deviation should be 5.916. Okay, that's for the calculator. So now kita kira manually using the formula. Cuma kita dah pakai tipu sikit tadi, nak cari summation ni kita dah boleh pakai calculator je. Okay, so now I substitute one by one into our calculator, into our formula. So start with summation of X squared. So we have 1801 minus with squared of summation X. So we have 117 squared divided by N means our data. So 9. The whole thing divided by N minus 1. So divided by 8. After that, awak tekan je lah calculator kira benda ni. Tadi kita dah tahu dah kan jawapan ni apa. Jawapan kita supposed to be 35. Okay. That's for variance. Next one is standard deviation. So standard deviation fixed formula is basically square root or surd of our variance. So here it is surd of 35. Compute this into your calculator, you should get 5.916. Senang kan? Memang senang lah, sebab tu lagi satu reason why this chapter tak keluar final exam. Sebab semua benda sebenarnya pakai calculator dah keluar jawapan. Sebab tu dah ada keluar kat bahagian assignment, so that you have to provide detailed solution. Everything that you compute into the formula, make sure kena tunjuk. Tak boleh terus saya highlight lagi sekali, walaupun calculator dah bagi jawapan, cannot simply let's say dia bagi soalan awak terus je S squared letak jawapan, S letak jawapan. Tak ada markah jalan kerja. Tak boleh. Okay. That's for the first one. Variance and standard deviation for ungroup data. Okay. We go to the next one. Group data pula. Okay. So what are the differences? For group data, for sure we must have class interval. Remember, kalau class interval, for sure dia akan jadi group data. So, before we proceed to compute all the data into calculator, all the frequency, we must find the midpoint first. Kita kena cari dulu midpoint. Okay. So remember midpoint upper boundary plus lower boundary divided by 2. So carilah satu-satu kat sini. So kita akan dapat apa tu? First one should be 8 and then 13, 18, 23, 28, 33 and last one would be 38. Okay, that is our midpoint. Okay, now we may compute all of this into our calculator. Sekejap ya, saya kecilkan balik skrin. Okay, kita masuk balik dalam calculator, the new data. Okay, go back to OPTN, option ni, button option. Pergi kepada number 3, data. Oh, okay, bukan. Sorry. Saya salah. Kan, kita tak boleh terus pergi ke data sebab sekarang, saya tunjuklah. Kalau kita terus pergi number 3, table kita ada satu ni je. Tadi X kan? Tak boleh. Sekarang ni kita ada another column about frequency. So kita kena tambah column kat dalam calculator. Okay, how do we do that? Okay, go to shift, menu, and then go to the second page. First page ni tak ada apa-apa. Go to the second page. Ada number 3, statistic. Okay, so choose number 3. Dia akan tanya frequency on off. We have to on the frequency button. Okay, after that go back to option and then go to number 3 back data. Dah keluar frequency table. So you have another column here lah. Boleh kecap ke saya laju sangat? Saya ulang semula lah about the frequency ni tadi. Okay, katalah saya clearkan balik dulu calculator saya ni, reset balik Okay, first shift, menu. Okay, first option ni tak ada apa-apa. Go to the second, tekan button bawah. Go to the second page. And then akan keluar number 3, statistic. Okay, statistic. And then dia akan tanya about frequency. So you have to choose number 1 on the frequency. Okay, and then kita nak masukkan balik dalam data tadi kan. Go back to menu and then choose option number 6, statistic, 1 variable. So keluarlah table awak. We have X. X is the midpoint. Frequency is your frequency lah. Okay, so now we compute everything into the calculator. Masukkanlah satu-satu. Jangan terbalik pula tau. Jangan pergi X tu awak masukkan frequency awak masukkan midpoint. Jadi mengarut nanti. So jangan terbalik masukkan data Okay. 23, 28, 33, 38. Okay. So and then frequency is 1, 2, 3, 5, 4, 3 and 2. Okay, settle. Dah settle, tekan balik button AC. Not to worry, data awak takkan hilang. Okay, go back to OPTN just now. Choose number 2, calculator. Dah keluar juga lagi sekali. Okay. So remember there. Yang first tu min. Yang kita nak ni kan, second row, summation of X and then summation of X squared. Okay, after that yang sigma tu jangan tengok, ingat S squared is actually the answer for our variance. Next page, S is actually the answer for standard deviation. Okay, kita dah ada kat situ. Alright, now we transfer this into our formula. Saya highlight balik je lah. Okay, we have 3 info just now. First is our frequency. Itu kita nak pakai nanti kat sini. Frequency N tu frequency lah. Altogether kita ada 20 runners, so 20. Next is summation of Fx. Frequency times with our midpoint. So this is 490. And then last one, summation of Fx squared. Frequency times with square of the midpoint. Lepas tu dia tambahkan semua sekali. Ni kalau kita kira manually satu-satu, quite leceh lah. A bit tedious. Tambah pula. Tekan calculator pun tersalah kan. Dapatlah summation mengarut nanti. So, I suggest make sure compute everything. Compute every single data in the calculator carefully. Calculator akan kirakan yang betul lah. Instead of you finding one by one, awak pergi cari X. Betul awak cari X squared one by one. Betul awak kira frekuensi darab baru awak nak tambahkan. Jadi tedious lah kat situ. Okay. Alright, dah settle. Kita masuklah one by one into the formula. So start with the variance. Same formula as before but now we have Fx frekuensi kat situ. Okay, so start with summation of fx squared 13310 minus with squared of summation fx, so 490 squared divided by our frequency just now is 20, the whole thing divided by n minus 1, so divided by 19. So here our answer should be 68.68. Double check masuk dalam calculator tu tekan lah, make sure dapat jawapan betul. Okay, and then after that, for variance, it's basically standard deviation. It's basically standard deviation of variance. So set of 68.68, your answer should be 8.288. Okay, settle. That is for variance and standard deviation. Pay attention juga dengan notation saya highlight kat sini ni. S and S squared. Sometimes in the question, they didn't directly mention about variance and standard deviation at all. They just use the notation find S squared, find S. So you must know the notation for both. Okay, settle for group data. Cukuplah kan satu example sebab masuk calculator je pun. Okay, next one kita nak masuk about Pearson coefficient. Okay, what is Pearson coefficient? That is directly from the formula. After this, kita akan tengok formula. Why we want to find that? Because we want to interpret the distribution. This is another way, the most accurate one on how to interpret a distribution. Okay, so as usual, we have three types of distribution. First one, we will declare this as symmetrical distribution. When value of mean exactly the same as median, exactly the same as mode. Okay, so the best measurement in this case would be mean, sebab mean yang duduk tengah, dia semua sama. Okay, second interpretation would be about positively skewed or skewed to the right. Okay, so if this happen, means median would be in the middle between mode and mean. So best measurement would be median. And then last one, our comment would be negatively skewed or skewed to the left. So best measurement is still median, but then the reason would be the other way around because median lies between mean and mode. Kedudukan mean dengan mode tu terbalik untuk positively skewed and negatively skewed. Okay, so how do we find the distribution? How do we comment? Okay, so this is the formula for Pearson coefficient. Sorry benda tu macam stretching sikit kan. Okay, so Pearson coefficient of skewness formula, we have two different formula, depends on the situation. So first one would be 3 times with mean minus median over standard deviation, or the second one would be mean minus mode over standard deviation. You can use either one, depends on what you have found before. Selalunya kita nak guna yang mana satu, tengok soalan sebelum minta cari apa. Kalau soalan sebelum dia suruh cari mean, lepas tu dia cari median, then you use the first formula. Kalau let's say soalan ni tak suruh cari median, dia suruh cari mode, then you use the second formula. Both formula will provide the same final distribution lah on how to comment. Maksudnya bila kita cari dua-dua tu, jawapan memanglah akan berbeza kan, tapi kita punya interpretation still the same. Okay, alright, so how do we comment based on Pearson coefficient skewness? So if it's exactly 0, then we would say it is symmetric. If it's positive, then we will comment as positively skewed. If it's negative, then it will be negatively skewed. Senang je. Kalau betul-betul kosong, exactly 0, then kita akan kata benda tu symmetric. Kalau dia dapat positif, kita cakaplah dia positively skewed. Kalau dia negatif, kita cakaplah dia negatively skewed. Itu sahaja. Okay, so let's do example. Kita ada 3 example. Okay, example next one. Given this data, this is for sure group data because we have class interval here. Find mean, median, mode, variance, standard deviation, Pearson coefficient of skewness, and then after that interpret data, state with a reason. Okay, the first 5 things ni, A, B, C, D, E, saya tak buat bersama-sama awak. Saya bagi jawapan akhir je because you for sure can find this on your own using calculator dah dapat jawapan. So itu awak kira sendirilah. Saya terus bagi jawapan akhir je. Okay, for mean we should get 34.1. Median is 30.75. Mode 23.5. Variance is 254. And then last one, standard deviation would be 15.937. Okay. Itu semua benda kita dah belajar sebelum ni. Make sure you try on your own Janganlah tak try langsung. Nanti tak tahu faham ke tak faham sebelum ni belajar kan. Okay. Saya dah bagi final answer je. Because now kita nak fokus the last two. Okay. So find Pearson coefficient and then interpret our answer. Since this is our first question, so saya guna dua-dua formula lah. Okay. Pearson coefficient or our notation is SK. Highlight juga SK. Sebab sometimes keluar juga soalan. Dia tak cakap find Pearson coefficient. Dia cakap je find SK. Okay. So for SK, the first formula would be 3 mean minus median over standard deviation. So I just compute one by one. So 3 times with 34.1 minus with our median is 30.75 divided by the standard deviation 15.937. Okay. Lepas tu, awak tekanlah calculator. Saya bagi masa untuk awak tekan calculator yang dapat apa jawapan tu. Okay. Dah kot, dah tekan calculator Alright. So, for the first one, our Pearson coefficient should be 0.63. Okay. That's for the first formula. Or we can use another one, the second formula, second option is mean minus mode divided by standard deviation. Okay, so for this one, we would have 34.1 minus with 23.5 divided by still the same standard deviation, 15.937. Okay, for this one, sama, saya bagi masa, tekan calculator. Okay, you should get 0.67. Nampak? Both would have different value but still in the same range lah. Dia takkan pergi jauh. Takkanlah satu tu dapat positif, satu dapat negatif. Yang tu tak logik. Tu something wrong dengan data awak sebenarnya. Okay, jawapan dia memang akan slightly different tapi takkan jauh sangat. Takkan jauh beza. Okay, settle. This is how we find Pearson coefficient. Next, how do we interpret our answer? Because our SK just now is positive, it's greater than 0. So our comment is, it is positively skewed. Senang je kan? Jawapan positif, positively skewed. Or, kita boleh cakap juga, our data is skewed to the right. Gitu. Sebab data kita lebih cenderung skewed to the right side. Skewed to the positively side. Positively skewed or skewed to the right. That is for interpretation. Itu sahaja komen dia. Jangan pergi komen ngarut-ngarut. Tiba-tiba nak pergi cakap benda lain pasal apa? Dispersity, consistency tadi yang standard deviation. Tak ada. Jangan tiba-tiba suruh komen about standard deviation. Awak pergi komen pasal skewed-skewed. Soalan suruh komen pasal Pearson coefficient, awak pergi komen pasal disperse dengan consistent tadi. Terbalik. So, kena ingat, how do we interpret the data based on what you have find before. Okay, settle. That's for F. Next one, G. State with a reason where the mean or median is a better measure of location. Yang mana lagi bagus untuk situation macam ni. Okay, so ingat, kalau mean, yang paling bagus mean if it's normal. Symmetrical. The other two case untuk positively skewed or negatively skewed, better measurement would be median. So in this case, it is median. Why? Dia katakan reason dia, because if it's positively skewed, means that median would be the middle between mode and mean. Bila kita dapat data yang positively skewed, maksudnya kat situ, median tu yang data tengah-tengah antara mean dengan mode. So, dia lah yang paling tepat. Dia yang paling bagus. Okay. That's for this example. Kita pergi next example. Example 22. Okay, so the following table give a cumulative frequency. Careful here. That's cumulative frequency. So, dia F besar. Okay. Okay. So, from here, we have to find mean, median, and standard deviation. After that, we have to find the Pearson coefficient skewness and interpret our answer. Last one, state with a reason whether mean or median is a better measure location. Okay. So, for this question, hati-hati first dia dah perangkap kat sini. Dia bagi cumulative frequency, not frequency. So, you have to find the frequency on your own. Awak kena cari dulu frequency awak apa. Okay. Kalau selalunya dia bagi frequency, kita kena cari cumulative frequency. Yang ni terbalik. Dia bagi cumulative frequency, we have to find frequency. Tapi terbalik je lah proses dia kan. Kita kena tolak instead of tambah. So, start with 0. Next one would be 5, 10, 13, 12, 10. Kita tolak je. Frequency, cumulative frequency minus cumulative frequency before. Dapatlah frequency. Okay. Next part about midpoint. X mesti cari. Midpoint you have to find because ini yang kita nak masuk dalam calculator. Okay. But then problem pula. Because the interval tak nampak lower boundary. Nampak macam data yang tergantung kat situ kan. Ini soalan famous. Dia selalu keluar pattern macam ni. Sebab dia nak tahu awak reti nak adjust the interval. Okay. So this is inequality. Data kita mesti bersambung if it's involved inequality like this. Okay. So based on the first interval kelas ni, we have 2.5. Tapi dia less than 2.5. Dia not exactly at 2.5. So 2.5 akan pergi kat mana? 2.5 akan pergi to the next class. Dia akan ada equal kat situ. And then biasa data kita ada X kan kat tengah-tengah. Itulah kelas interval kita from 2.5 up to 5.5. Sama juga untuk the next one. It's less than 5.5. So means 5.5 goes to the next interval. Okay. And then dia pergilah 8.5, 11.5, 14.5. That's how you rearrange back our class interval. For the first class, adjust pun tak apa because dia punya frequency is 0. Kalau 0, dia tak termasuk pun dalam data kita. Tak ada dalam calculator pun. Tak perlu isi. So, kita leave it blank pun okay. Alright. So, next, find the midpoint. Ingat, midpoint, upper boundary plus lower boundary divided by 2. So, here we should get 4, 7, 10, 13, 16. Okay, settle. Now, we have to compute all of this into calculator. Saya bagi masa sekejap lah, 1 minit. Masukkan data yang baru. Frekuensi ni F dengan X, your midpoint, into the calculator. So, that senang kita nak cari mean, kita nak cari standard deviation. Okay, dah kot. Dah settle masuk calculator. Kita check awak masuk calculator betul tak. So, summation of F, frekuensi ni kat dalam calculator kita dah tahu dah tadi, 50. Summation of Fx should be 536. And then summation of Fx squared should be 6458. Kalau dah tahu tak sama dengan saya, maksudnya tersalah masuk calculator lah tu. Okay. So now using this, we have to find all the question. First one, we have to find mean. So mean is summation Fx 536 divided by total of frequency 50. Okay, so here our answer should be 10.72. Or masuk calculator tadi, awak dah boleh check dah. The first one is about mean. Jawapan awak patutnya masih sama dengan yang dalam table tadi. Okay. Second one, we have to find the median. So, median tak ada dalam calculator. Dia tak boleh check kat situ. Okay, so kita kena kira yang ni manually lah. Alright, so remember, before finding median, you have to check the class first. Kita kena cari dulu class median ada kat mana. Macam mana nak cari class median? It should be half of our data. So, half times 50 should be 25. Okay, cari bahagian cumulative frequency. 25 lies on the class interval. Ini yang saya highlight ni. Okay, that will be our class median. Highlight dua benda. Remember, we must use cumulative frequency before. So, 15. Frequency of our class. So, 13. That's two things that we need in our formula. Cumulative frequency before and then frequency of the class. Okay. And then kita kena fokus dia punya lower boundary. So, lower boundary is 8.5. Ini item yang kita nak guna. Okay, saya masukkan satu-satu dalam formula. So, start with lower boundary. Remember, 8.5 plus with half of frequency. So, half of 50 minus cumulative frequency before. So, 15 divide by frequency of median. Frequency of class median times with size of our class. So, 3. So, in this case, saya bagi masa, tekan calculator. Alright, so your answer should be 10.81. So, that's for median. Next one, we have to find the skewness. Standard deviation dulu. Standard deviation tu tinggal. Standard deviation. Sekejap saya tarik ke tepi lah. Tak muat dah. Okay. So, standard deviation, remember the formula, it is surd of variance. So, surd of summation fx squared. So, kita ada 6458 minus with squared of summation fx. So, 536 squared divided by frequency 50. The whole thing divided by frequency minus 1. So, 49. Here, our standard deviation should be 3.58. Kalau tak nak terus buat wanggu macam ni, awak nak buat satu-satu. You want to find the variance first. After that, baru awak setkan to find the standard deviation. Boleh, tak salah. Up to you. Yang ni saya terus wanggu je lah. Sebab soalan memang tak suruh cari variance. Okay. Settle. Moving on, part B. We have to find our Pearson's coefficient. So, kat sini kita dah ada mean and median. So, use that lah. Kita gunakan yang itu. So, if mean and median, kita kena times by 3. So, 3 times with mean 10.72 just now, minus with our median 10.81 divided by standard deviation. So, 3.81. Tolong kira. Okay, so you should get negative 0.07. And then we have to comment on this data. Okay, yang ni kena highlight sikit. Even though it is negative, but then it very small value dia. Not even 0.1. Okay, so kalau kita jumpa jawapan in the range, kita punya SK ni in the range of negative 0.1 up to, tak nak 0.1 lah, nanti kan main confuse tak, 0.09 up to 0.09, negative 0.09 up to 0.09. Antara tu 0.0 lah, belum lagi 0.1 tu. Then kita akan assume our distribution as symmetrical. Almost, dia tak exactly symmetrical, dia almost symmetrical. So, almost symmetrical. Kita tak letak dia, apa komen kita tak cakap dia skewed to the left, kita tak cakap dia skewed to the right. Dia bukannya positively skewed, dia bukannya negatively skewed, dia almost symmetrical. Because range dia tadi lah 0.0 tu Okay. So, settle, that's for B. And then last one for C. C tadi apa yang soalan dia? Sekejap, lupa dah. C, state with a reason whether mean or median is a better measure of location. Okay. Siapa lagi bagus sekarang ni? If it's almost symmetrical. Okay. Kalau almost symmetrical, kita kena tengok kepada rujukan untuk symmetrical. So, rujukan untuk symmetrical kita akan guna. Sekejap saya tulis. For symmetrical distribution, kita akan cakap mean yang lagi bagus. Location. Okay, kenapa? Because for symmetrical distribution, basically value of mean almost the same as median and mode. So, mean akan duduk tengah-tengah. So, mean is the better measure of location. Okay, mana nak rujuk ni? Ada dalam nota kuliah awak. Refer kat situ. So, konsep dia sebenarnya, kalau ada symmetrical distribution, mean paling bagus. If it's positively skewed or negatively skewed, median yang lagi bagus. Dua je jenis dia, antara mean dengan median. Mode memang kita takkan pilih langsung. So itu je lah. Okay, cuma nak highlight kat sini, even though it's negative, tapi dia tak sampai 0.1 lagi. So we comment that as almost symmetrical. Kita tak cakap dia negatively skewed, kita tak cakap dia skewed to the right. Walaupun nilai dia negatif kat sini. Sama jugalah kalau ada 0.07, kita takkan cakap dia positively skewed or skewed to the right. Kita still guna comment almost symmetrical. Okay. Alright, that's for this question. Kita pergi last question for today. Alamak, dia nak ambil masa. Kita pergi laju. So, the following table shows score for maths test for 100 KMJ student. Compute the Pearson coefficient of skewness and state the shape of the distribution. Okay, kita suruh cari SK. Lepas tu state the shape of distribution. Alright, no problem for that. And then next part, given the average score for physics is 69.25 with standard deviation of 9.81. Determine which score is more stable. Mana data yang lagi bagus? Budak ni dia bagus kat fizik ke dia bagus kat math sebenarnya? Itu yang dia suruh kita analyse. Okay, we go to the first part first. We have to find the SK and then kena cari dia punya distribution. Okay, sebab nak cepat saya bagi info jugalah Ini awak boleh kira pakai calculator sebenarnya. So remember this is group. So you have to find the midpoint. Tapi saya tak tunjuk kat sini. Awak boleh masuk terus dalam calculator. Summation of fx should be 6745. Okay. And then summation of fx squared should be 455,803. Okay. And then after that dah masuk dia, awak boleh dapat dalam calculator kan dia answer. So saya tak tunjuk dalam kerja, kita ambil data terus Mean should be 67.45. Sebab summation effect tadi dah 6745. We have 100 student. Divide those two, dapatlah 67.45. Okay. And then next info kita perlukan apa? Dia punya standard deviation. So standard deviation should be 2.93. Ini semua yang dah ada dalam calculator. Make sure you choose the correct data, choose the correct midpoint. Okay. But dia nak cari ni kita tak lengkap lagi. Kita mesti ada median or mode. Salah satu. Mean dah ada. Kita pilih lagi satu je. Median or mode. Soalan sebelum tadi kita dah cari median. Soalan ni saya kasih kita cari mode lah Okay. Mode, remember, choose your class mode first. Class mode is class with the highest frequency. So here 66 up to 68. That would be our class mode. So lower boundary, because kita punya data ada gap, lower boundary you must minus 0.5. So 65.5 plus with, remember formula D1. D1 is frequency of the class 42 minus with frequency before. So minus 18. Over the same thing, D1 plus D2. What is D2? Frequency of class mode minus frequency after class mode. Minus 27. Times with size of our class. So 3. Okay. So this one you should get 67.35. That's for mode. Okay. So next we can find the Pearson coefficient. Okay, kita terus cari. So now our SK using the formula mean minus mode. So 67.45 minus with mode 67.35 divided by the standard deviation just now 2.93. Okay, in this case our answer should be 0.034. Okay. So 0.034. Next after that we have to interpret this. Ini pun sama lah ni. Dia tak sampai 0.1 lagi kan. So our comment would be almost symmetrical. Tapi kalau lah awak tak letak almost symmetrical biasa macam ni, awak still jawab positively skewed. Most likely orang akan terima jugalah. Sebab value dia memang positif pun. Cuma almost symmetrical lebih accurate. Okay. Settle for that. Next part. Given the average score ni tadi, dia suruh pilih data mana yang lagi stable. Okay, kita list down back our data just now. Okay. We have two different data. First one is for maths. Next one would be given in the question is about physics. Dia kata dia ada average. Average is basically mean. Okay. For maths just now, mean is 67.45. Physics will be 69.25. And then kita ada standard deviation. Maths is 2.93. Physics will be 9.8175. Okay. Data yang lebih stable or more consistent. If we refer to the average or our mean, means physics nampak lagi, average lagi tinggi kan? Average lagi tinggi, lagi bagus lah. Okay. But then, if we compare value for the standard deviation, sangat jauh beza dia. Maths is much lower than physics. Maths tu baru 2.93. So, standard deviation dia lagi rendah daripada physics. Okay. So, here, we can comment that, okay, maths more stable compared with physics. Why? Kenapa? Because data or marks. Soalan ni kita tu pasal markah kan? Marks pula. Okay, marks for maths. Kenapa benda ni? Ingat syarat kita tadi. Is less dispersed. Kita kena komen pasal dispersity and more consistent. Itu je cerita dia. So kat sini kalau nampak tu siapa yang lagi rendah nilai standard deviation, dia yang lagi bagus. Soalan ni tanya kenapa dia lagi stable kan? State with a reason. Sebab markah math ni kurang disperse, lebih konsisten compared with markah fizik. So maksudnya markah math yang lagi stable. Okay. Alright. Habislah about 6.3 standard deviation, variance and Pearson coefficient of skewness.